Well, welcome back. We're going to take a look at some material that involves flat surface figures from geometry, which help us better understand why bridges maybe vibrate and also understand why railroad rails are the way they are. So we're going to do a little introduction to flat surface figures right now. So here we go. All right. You're familiar with flat surface figures. You saw them in 6th grade, 5th grade, all the way through school. Let's take a look at one of the most familiar ones, the circle, right? Although the circle is a flat surface figure, you notice none of its sides, or its side is not made out of line segments like most flat surface figures you think of, but a circle is an example of a flat surface or plane figure. The more familiar one you might be aware of is the square, which you see right here, obviously. Okay, from middle school, you remember that very well. And of course, your good old buddy, the rectangle, all right? So those are 3 examples of flat surface figures you should be quite familiar with. Let's go down here and look at a couple more. How about the parallelogram? The opposite sides are both equal in length and parallel in a parallelogram. And you recall also there were, trapezoids. Trapezoid has 1 pair of sides parallel, opposite sides parallel. The other 2 are not, okay? But you notice there's a figure missing that I haven't talked about yet, which is very popular and you spent a lot of time studying in geometry. And that figure just happens to be the good old, well, I don't know, it's not here yet. Well, I got ahead of myself a little bit there. So let's look at 3 more figures, and then I'll go back to that figure I was talking about. So there's a pentagon, and of course it's a 5-sided, what we call polygon. Remember, polygons have all sides that are line segments, just like the trapezoids and the parallelograms and so forth. But this is called a regular polygon because all of its sides are equal in length, and all the angles on the inside of the figure are the same. All right. Next, we have a regular hexagon, a 6-sided polygon. All the sides are equal in length, they're congruent, and all the interior angles are exactly identical. And last but not least, we have our favorite, the stop sign. And the stop sign, of course, is a regular octagon, 8 sides. But the figures we have not talked about yet that are very important to bridge structure, very important to railroads, very important to everything that we do in the construction world is, of course, the triangles. And if we take a look at the triangles, okay, there are various types of triangles we should talk about. The most simple triangle that you ever dealt with was called the scalene triangle. The scalene triangle has all sides different lengths. All the interior angles are different as well in measure. And remember that those angles do have to add up to 180 degrees. So you don't want to forget that. Okay, the next type of triangle that you're probably very familiar with is the good old isosceles triangle, I-S-O-S-C-E-L-E-S. In an isosceles triangle, 2 sides have exactly the same length. And if you recall, the base angles that are down here are also congruent or equal in measure. Well, in addition to those 2 triangle types, we have another one which is very popular, the equilateral triangle, where all sides are exactly the same length. All 3 interior angles add up to 180 degrees and are each 60 degrees, or equal in measurement. But the triangle which is probably the most important that you discussed in your career because of its importance is the right triangle. And the right triangle, of course, has 1 right angle in it. The reason it only has 1 is the other 2 angles only have 90 degrees to share between them, since triangles add up to 180 degrees, they're angles. So therefore, the right triangle is, of course, very important. And of course, you're very familiar with the right triangles because of a guy named Pythagoras, who was an ancient Greek. And let's go to our next page here now and take a look at a typical scalene right triangle. If you recall, in a scalene right triangle, okay, the side, well, in any right triangle, the side which is opposite the right angle, across from it, is called the hypotenuse. So I'll put an HYP up here for an abbreviation for it. and it is denoted in a right triangle as being the side C. And you're familiar with the fact that the side that's vertical over here, which is kind of like the altitude of this triangle or height, is referred to as A. It's one of the legs of the right triangle. And of course, the base on the bottom is denoted usually by the letter B. And of course, it is, again, I mentioned the base of the right triangle and usually is referred to as the letter B. Often the angles in the right triangle are capital letters. That's a capital C for the right angle. And the angle that's opposite this particular side is also referred to with a capital letter matching that side. So that's angle A, and angle B would be up there, okay? So the formula that you remember from middle school and high school is the rule of Pythagoras, or the Pythagorean theorem. Do you remember what it says? Well, this is what it says. It says if you take the hypotenuse and you square it and add to it, or add together, the sum of the squares of the two legs, lengths, those two values squared will add up to the length of the hypotenuse squared. It can also be written in the other direction, written this way, and you use it whichever way the formula best fits what you're looking for, okay, in terms of a problem you might be solving. So there is the typical rule of Pythagoras, which I would like to talk about a little more extensively right now, just as a review for you, okay? So let's go on. There's the formula again and the right triangle. The worksheet, group work 17, is designed for you to practice a little bit with the rule of Pythagoras, okay? And we're going to do that together right now. I want you to assume that the figures talked about on this sheet are all right triangles, okay? It doesn't say that on your sheet, but these are all right triangle problems, all right? So they're all right triangles, so please remember that when we're doing them. Okay, it says find the missing sides given the following information. Well, in 1A, we're looking for C, which is the hypotenuse of a right triangle if its legs are 40 and 56. So let's take a look at that. I'm going to write the formula out first. So I'm going to kind of write in the middle here. You probably shouldn't write in the middle on your sheet, so you have more room, but you also have the back of the sheet you can use. But at any rate, I'm going to write the formula a squared plus b squared equals c squared. Well, wait a minute. I'm missing c, right? So I might have written the formula the other way. So I think I'm going to do that. I'm going to erase this, and I'm going to go back, and I'm going to write the formula. Since I'm missing c, I'm going to write it this way. And if you recall, c we don't know, so if I square it, and I add to it the length of a, which is 40 squared, and I add the length of b to it, squared, which is 56, I should get the value of x squared, and then I can take the square root of the sum I get for those two figures, and I should have the length of x. Well, I can remember that 40 squared is 1600. That I do know, but I can't remember what 56 squared is. So what I'm going to do is bring up the calculator so that I can do that, all right? So I have to stop sharing here, and I have to go up and share again. And when I do that, I'm going to share the calculator with us. Okay, let me get rid of this mess here. Gotta delete that thing. So I'm going to share the calculator here. So let's do that. And what I'm going to do is I'm going to square 56 on it. So if you remember, all I have to do is simply do 56. And on your calculator you were using in class a lot, it was x squared, all right? So you just hit the x squared key and you get the answer 3136. So I'm going to go back in a moment and put the 3136 in there. But if you recall from looking at your sheet, I'm going to be adding 3136. So So I'm going to hit plus here, and I'm going to add to it the 1600 I already got. All right, so I'm going to do that right now. And you see the answer I get is 4736. Now, what do I do with the 4736? Well, what I do is I take the square root of it, right, to determine the length of the hypotenuse. So I'm going to do that right here while I'm here with the calculator. So I hit second x squared, and I hit 4736, enter. And notice the answer does not come out even. And it looks like it's one of those crazy irrational numbers. So I'm just going to round the answer off to the nearest tenth. So it's 68.8. I'm going to remember. I'm going to write that down. And I'm going to take the square root. For show, I took the square root of 4736 on my paper. And I have the 3136, okay, that I'm going to also write on my paper. So I'm going to go back to the paper now. So I will do a new share. Oh, I've got to clear that off first. Sorry about that. So I'm going to take that down like so. And now I'm back on this sheet here, hopefully. Let's see if it lets me see that. It does. So I will now share with that one. And we're back to this sheet. So it's now 3136 I would write here. So this is 3136. When I added the two together, I got 4736. To determine the value of x, I had to take the square root of each side of the equation, or in other words, take the square root of 4736. And when I did, I got approximately 68.8 for the answer for the side that is the hypotenuse of this right triangle. Okay, now I'm sure you've had a chance to write that down. So what I'm going to do now is erase all that, and I'm going to do the second problem. So let's do that right now. So let me erase this. Okay. All right, and now I'm going to do the second problem. In this case, I have C, the hypotenuse. I'm looking for side B. It doesn't say that on here, but it should say up here, find B is equal to how much? Or in other words, I need to find B, okay? So let's do that. This time I'm going to use the formula this way, okay, since I have the hypotenuse. So I fill in the values where they belong. It's 88 squared plus B squared has to equal 187 squared. This is a 7. Make sure you know that. It's not a 2. Okay, so now what I'm going to do is switch back to hopefully the camera view on the calculator, and I'm going to square those two numbers, and I will realize that what I'm going to do is come back to this screen in a moment, and maybe you can do some of this on your own calculator or your phone so that I don't have to switch back to the calculator. So let's go back to a new share. Let's go to the calculator. Let's share that. Now I am going to square, right, the following two numbers. I'm going to square, where'd they go here? I seem to have lost them. Where are they? Well, I've got to go back. So let me do this. Let's stop the share. I got to go back to this screen for a moment. All right, I'm going to square 88, and I'm going to square 187. Okay, so now I will go back, and I will reshare that screen with the calculator on it. Okay, so I'm going to clear this. I'm now going to square 88. So all I have to do is hit 88 x squared, okay, and hit enter, and I get 7744. So write that down, please, under the 88 squared. I'm now going to do 187, and I'm going to square that. So I do x squared and hit enter, and I get 34,969. Okay, now what do I do with those two numbers? Well, if I go back to the other screen briefly, All right, I will see that. So what I have to do is I have to go back here and put the answers I got for those two squares down here. 7744 plus b squared equals 34,000, okay, 690, or excuse me, 969. Let me erase that, sorry. So it'll be 34. Well, I'll be all right. 34, 969. Okay, to isolate b squared, I'm going to have to subtract 7744 from each side of this equation. So when I do that, I will obtain b squared, which I probably should have called x. I didn't, but that's okay. I can just leave it as b squared. Now, when I subtract those two, I'm going to tell you without going to the calculator screen that I get 27,225. So to get b, what I have to do is take the square root of 27,225. And whatever I get for b will be the length of that leg, which is usually referred to as the base. So what I'm going to do is I'm going to go back and share now the calculator again with you. So now I'm going to take the answer I got, which was 34,969, okay? So I'm going to hit subtract. So 7744, all right, and I'm going to hit enter, and I get 27,225 like you saw before. And now what I have to do is get the square root of that. So if I do second and I hit x squared, which will give me the square root, and I enter 27,225, you can see that I obtain 165. Wow, it came out even. Imagine that. So let me share back here. Okay, let's do a new share with this one. And I got 165 for that answer. Okay, so B is 165. Do you recall from your past in mathematics what it is called when you get three whole numbers that fit the rule of Pythagoras? In other words, the answer 88, 165, and 187 has a name. And it is called a Pythagorean triple because these are three numbers that fit the rule of Pythagoras, okay, in such a way that they come out exactly even, no irrational numbers, okay? Now we're going to talk more about that in a video I'm going to show you later in this presentation, okay? So we'll come back to that. All right, let's look at question 2 up here while we have the opportunity, all right? Suppose someone tells you that she or he has a triangle with sides of lengths 2.6, 8.1, and 8.6. Is this a right triangle? Why or why not? Well, how can you prove that it is or is not a right triangle? Well, to do that, I pretend that the sides are indeed fitting the rule of Pythagoras correctly to make it a right triangle. And I show whether or not the statement is really true. So I write down a squared plus b squared equals c squared. I put the numbers in there, 2.6 squared plus, now 8.1 would have to be the other leg, right? Squared. Does that equal 8.6 squared? Why did I know to put 8.6 down for c? The reason I did is because 8.6 is the longest side in the triangle, so therefore it would have to be the hypotenuse. Okay, what I'm going to do is square these, but not show you on the calculator. If you square 2.6, you obtain 6.76. If you square 8.1, you get 65.61. Is this the same thing as 8.6 squared, which happens to be 73.96. Well, if you add those two numbers together, you will find out you do not get the number we expected, okay? And the number we expected was 73.96, but instead you get 72.37. Well, that's not equal to 73.96. Therefore, what? Not a right triangle is the conclusion. Okay, so there's another example of how we can see whether or not we indeed have a right triangle. Now we're going to talk about problem 3, but we're going to talk about it with another video. And I'm going to show you 2 videos in a row that deal with this topic that's in the next question. Let me go here. Why do we hear a clickety-clack sound when we ride on a train or on the subway? Okay, well, you can see right here there's a space here between where these 2 rails go together. This doesn't look like it has any spaces in it between the rails, but this one definitely does. All right, well, as it turns out, you're going to see that train tracks, of course, are made of metal. And when riding a train, you hear the clickety-clack of the wheels as you go down the tracks, okay? And it's because of the gaps that have been left in the tracks. What is the reason for these gaps? Well, you can see right here, I have the links for 2 videos that you are about to watch, okay? And those links are shown separately in the email. So now what you want to do is go back to the email and watch these 2 videos. I do want to warn you, the first video is pretty goofy. Second video is a little more normal. So take a look, okay?